Assalamualaikum warahmatullahi wabarakatuh, and good morning to Mrs. Nadira binti Norzalan and to all my friends. Today we will going to present about case study for DCC 30093 for Geotechnical Engineering. But before that, let me introduce our group mate. Starting with me, I, Muhammad Syamil bin Rosli, 16 DKA 21F1015, with my friends Nurin Alia Batrisha binti Muhammad, 16 DKA 21F1006, and Nur Izzatul Alia binti Norizan, 16 DKA 21F1017. So, in total, there are 9 agenda that we will explain in this video presentation. Firstly is abstract. Landslides are the main focus of slope engineering today because of the rise in their frequency. The majority of landslides occur on slopes created by humans, and they are essentially a result of the uncertainties brought about several underlying causes. The study investigates the factors that contribute to the landslide at Highland Tower in 1993 using a reliability analysis technique and accounting for human error. It is a known truth about the probability of failure obtained from the statistical reliability study in conditional and exclude the effect of people. The methodology taken into consideration in this study is based on Monte Carlo simulation, with the stability of the slope being assessed using commercial slope with software. This software was chosen because it meets probabilistic and deterministic modulus, which yield more accurate results. Inquiries like these are followed by fault tree analysis (FTA), which calculate the likelihood of a landslide governing certain scenarios in order to quantify the human error sources of failure. The FTA findings indicate that the poor drainage, a crumbling rubble wall, and a weak rail pile foundation are possible causes of this landslide, confirming that human error play a significant role in its occurrence. In order to address the risks associated with the slope, the study advised using a human reliability analysis technique in addition to statistical analysis. Next is introduction. For location, the chosen location is Taman Hillview, Hulu Klang, Selangor, which is Highland Tower. The tragedy at Highland Tower is one of the worst tragedy that has ever happened in Malaysia. It happened in 1993, where there was a collapse of Highland Tower which killed 48 people. The collapse of Highland Tower is related to landslide caused by improper soil testing. Highland Tower consists of 3 12-story blocks of apartment known as Block 1, Block 2, and Block 3. Heavy rain on December 11, 1993 had caused retrogressive landslide behind Block 1, which consequently induced the instability of rail pile foundation. After the collapse of Block 1, the residents of Block 2 and Block 3 were prevented from entering their apartment by MPAJ to avoid the same tragedy happen. For detail of slope, Highland Tower site is located in Hillview Park, Hulu Klang, Selangor. The slope height of Highland Tower is 48 meters as worked out through reduced level. The soil above the highly weathered granite zone is generally classified as silty sand of medium to dense, overlain by silty sand of very loose to loose consistency. The clay mineral, which were the active component of the soil, were found in amount ranging from 15.3% to 37.4% only. Gradient of the Highland Tower is estimated through working hill slope range from 20 degrees to 30 degrees. Soil properties from undamaged mass of Highland Tower is effective cohesion is 4 kPa to 6 kPa. Friction angle is the range of 33 degrees to 41 degrees. Bulk unit weight is 90 kN per meter square. For dry unit weight is 16.5 kN per meter square, and pore water pressure ratio is 0.1 and 0.4.
Triggering mechanism and reason of failure. The collapse of the Highland Tower was triggered by a small stream behind Block 1 that had been diverted through the drainage system and joined the water flow from the development project at Bukit Antarabangsa. The collision of these streams had caused the drainage system to fail to function properly. This situation was when the area rain, which continued for 2 weeks. The rainwater has seeped through the cracks in the soil and produced underground flow. Behind Block 1, there is watery land and more ponds and marshy land on the west side of Block 3. The excessive amount of water seeping into the ground in very large quantities, causing the soil to become soft and move down the slope. Furthermore, the piles supporting the 48-meter high building only support the building structure from below, not from the sides. Because of that movement, it also dragged the structure supporting the building and caused the steel bars embedded in the concrete to bend and cause the entire building to fall forward. In addition, there is also an underground limestone cave near Block 1 that collapsed and caused the ground to become unstable, which was also one of the triggers for the Highland Tower to collapse. The negligence of the people concerned in the construction and maintenance of the structure was one of the factors that lead to Highland Tower's collapse. Following through consideration, MPAJ can pinpoint a number of causes, including: first, following Highland Towers in 1993, the agreed upon drainage system for the hillside has never been implemented. Second, slope and rubble walls behind and in front of Block 1 were improperly designed, having factor of safety (FOS) less than 1. Third, the foundational weakness of rail piles. In situ measurements of field instrument and laboratory tests. There is several laboratory tests that have been carried out at the Highland Tower construction site, which is: number 1, the field instrument or laboratory test is soil classification. The purpose is soil grouping. And then number 2, field instrument or laboratory test is shear box, and purpose is soil shear strength. Number 3, the field instrument or laboratory test is mineralogical analysis. The purpose is soil mineral. Number 4, the field instrument or laboratory test is petrographic study. The purpose is rock type. Number 5, the field instrument or laboratory test is surface infiltration. The purpose is permeability. Number 6, the field instrument or laboratory test is borehole permeability. Purpose is permeability. Number 7, the field instrument or laboratory test is field density. The purpose is soil weight. Number 8, the field instrument or laboratory test is compression test. Purpose is compressive strength of concrete. Number 9, the field instrument or laboratory test is tensile test. The purpose is tensile strength of reinforcement bars and rail pies. Number 10, the field instrument or laboratory test is bending test. Purpose is bending strength of reinforcement bars and rail pies. Number 11, the field instrument or laboratory test is impact test. The purpose is fatigue strength of rail pies. Number 12, the field instrument or laboratory test is chemical composition. The purpose is carbon content of rail pies. Number 13, the field instrument or laboratory test is inclinometer. The purpose is lateral movement of soil. 14, the field instrument or laboratory test is standpipe piezometer. The purpose is groundwater levels fluctuation. 15, field instrument or laboratory test is boreholes. The purpose is soil profile. And then 16, the field instrument or laboratory test is geological mapping. The purpose is extent of rock type and fracture zones. Number 17, the field instrument or laboratory test is seismic refraction. The purpose is subsurface lithology.
Calculation of factor of safety, FOS method or analysis method. So based on diagram 4, we have diagram of slope and the details, which is we got gamma 19, C4, gamma C 23.5, and then we have the length of the slope. So firstly we have to calculate the Ka, which is using formula 1 minus sin 33 per 1 plus sin 33, and then we calculate, then we got Ka equal to 0.294. So next we have to find PA1, which is 1 over 2 Ka1 gamma 1 Z1 Z1. So we have to fill in the value, which is 1 over 2 multiplied by 0.264 multiplied by 19 multiplied by 48 multiplied by 48, and then we get 6435.072 kilonewton meter. So PA1 equal to QH, so we have already QH over here, and then Y equal to 1 over 348, so we got 16 meter. And then we have to find PAY. PAY means PA multiplied by Y, so we fill in the value, which is we got it PA 6435 over 0.072, and then multiply by 16, and then we got 102961.152. And then we have to find QH multiply Y equal to PAY. So QH equal to PA is it? So just fill in back 6435.072 multiply by Y equal to PAY, which is we got 102961.152. And then we move, we got Y equal to 102961.152 over 6435.072. So we got Y equal to 16. Same like we already get it, the first one, which is 1 over 3 multiplied by 48, we got 16 also. So that's mean Y true. Also, and then we have the new diagram, which is we have to find W1, W2, W3. Sorry, W1, W2, W3 equal to like to find what we call it, to find the area of polygon. So the W1, which is the shape looks like triangle, so we have to use formula 1 over 2 multiplied by 2.5 multiplied by 38 multiplied by 23.5. So we got 11116.25 kilonewton meter, because the unit we use is meter. So and then W2, the shape looks like a rectangle, so we use the formula 12.5 multiplied by 48 multiplied by 23.5 equal to 14100 kilonewton meter. And then W3 also the same like W2, so we just fill in the value, which is 10 multiplied by 12.5 multiplied by 23.5. So we got 2937.5 kilonewton meter. So after we find W1, W2, W3, we have to find QV. So QV means W1 plus W2 plus W3. So we just plus the answer. So we already find, which is 18153.75 kilonewton meter. Okay. Next, we have to find X bar, which is X bar using the formula QV multiplied by X bar equal to PAY plus W1X1 plus W2X2 plus W3X3. So we fill in the value, and then we got X bar equal to 7.454 meter. Alright. So the other calculation factor of safety using others method, the result has shown at the table below, which is method ordinary, the moment which is 1.425, and then the force, there is no force. And then the second method, which is by shock, the moment 1.499, there is no force also. And then method jambu, there is no moment, but the force we got is 1.403. And then the last one, which is Morgenstern price, the moment we got is 1.502, and then the force 1.503. And then purpose prevention and remedial measure for a landslide. There are various methods that can prevent landslide from occurring. Among them is to modify the slope geometry. The contractor who takes this responsibility must ensure that the slope design pass every standard set by the Public Work Department (JKR). In addition, on the structural side, chemical agents can also be used to strengthen slope material. Sperry pile structure and retaining wall can be installed to increase the stability of the structure. Next is to provide a subsurface drain at the foot of the hill slope to control seepage flow. In fact, there are many other methods that can prevent landslide, but all of them require detailed research but before implementation, because they are constrained by cost, magnitude and frequency of landslide. For the existing slope throughout Malaysia, the authorities must be responsible for regular monitoring or can also install an early warning system to monitor the condition of the land so that they can act early. In addition, maintenance such as drains and the like must be done periodically to ensure that the drainage and flow system run smoothly. The conclusion: as human uncertainty in construction is increasingly acknowledged as one of the major reasons for failure in civil engineering, it is necessary to handle this uncertainty by developing various standards to deal with it appropriately. In the case of Highland Tower 1993, it was discovered that human error played a major role in causing the landslide. Other possible reasons for failure include poor drainage, a collapsed rubble wall, and a rail pile foundation. It is widely understood that a structure dependability depends not just on technology but also on how well it's designed, construction, and upkeep adhere to understand. This study conclude that
my boys won't hesitate to run up on your boys. 엉덩이 빵빵빵 남자들은 탐탐탐 내 입술 냠냠냠 어디 가도 당당당 등장은 짠짠짠 띠자 팡팡팡 디스코 팡팡팡